Last week of school, guys. So today is Monday, and we are going to re-look at equations of trend lines. So last week we kind of introduced this concept, and today we're just going to practice identifying the slope and the y-intercept within a trend line, and then write its equation. So this data we have here, this is Henry's running pace. So we have distance run, and we have time it took to make those different runs. So it tells us the information in the table and corresponding graph represent the different distances that Henry ran during quarantine, along with the time it took him to complete each distance. So each of these points is plotted already, so we don't have to do that part. And there's also a trend line already drawn for us. So just make sure you're comfortable with this graph. Take a look at the little aspects of it. The x-axis is our distance in miles, so equally spaced 0 to 5. The y-axis, equally spaced, we're looking at time in minutes. So 10, 15, 20, 25, 30, so it goes in increments of 5, starting at 0, all equally spaced. So we're going to look at the questions based on this information. First, it says, is there a correlation between the distance run and the time it takes to run it? So we would look at our graph and see if there's any kind of a correlation. We obviously know this one's a yes because the trend line is already drawn for us. So we would say, yes, there's definitely a relationship. There's a correlation. I would even say it's a positive linear trend. And later it asks that. It says, for letter A, if so, identify if it's a positive linear trend, negative linear trend, or constant linear trend. Other option, if it's nonlinear. So this one's linear, and because it's going up and to the right, it is positive. If my data had been going down, that would be negative, and if it had been in a horizontal line, that would be constant. So we're saying yes, and I'm going to say this is a positive linear trend. As one goes up, the other goes up. Now we need to identify the slope. Remember, the slope means the change in y over the change in x. This doesn't necessarily mean the change from one data point to the next data point. And what I mean by that is I wouldn't really want to say, let's look at the change from this one to this one. Because if I redraw a line through those two data points, it would not look like my trend line. So we are looking for the slope between 2 points that fall on our trend line. Maybe that means you pick, let's say, this one and this one. That would be pretty accurate. I could find the slope between those 2 points a couple of ways. I could just count on the graph. Remember, this is going up by 5s. So up 5, 10, and over 1, right? So if I go up 10 and over 1, that would make my slope 10 over 1, which is 10. Another way I could do that is I could identify my ordered pairs. So 220, and this one is at 330. And I could just find the change in y divided by the change in x. Either option is not going to matter. I could have picked 2 different data points also. I could have gone from the 0 and maybe gone up to this one. It would be up 20 and over 2, which would give me the same ratio. However you do it, we're going to end up with a slope of 10. Next, it asks us to find the y-intercept of the linear trend. This means we're just looking for where it's crossing the y-axis. Remember that your y-axis is the vertical axis, so it's right here. If it doesn't look like your line is crossing the y-axis, remember that you can extend the line. So keep that straight line going, and then you can see where it's crossing. We are going to have instances like we did last week in one of those problems where it doesn't cross and you had a break in the graph. Those ones are tricky. This one is, there's no trick to it. It's crossing right here at 0, 0, which makes sense because if he runs 0 miles, it should take 0 minutes. So my y-intercept, I'm going to say it's crossing at 0, 0, which means my b value is 0. Next, it says, write the equation of the trend line in slope-intercept form. Just to remind you, this is slope-intercept form, y equals mx plus b. So I know my m value, and I know my b value. I'm just going to plug them in. Y equals 10x plus 0, which can be simplified to y equals 10x. So theoretically, this trend line can tell us exactly how long it would take Henry to run just by plugging in number of miles for X. Or I could plug in a total time for Y, solve for X to see how many miles it would be for that amount of time. So this is our equation. So his rate of change, he's running 10 minutes per mile, and we have an intercept of 0. So it says, will this equation make sense for all future data? So this assumes that he can keep a 10-minute mile pace forever. That's for you to decide. I'm gonna go with probably not. I can't imagine that he's gonna keep that up, let's say for 24 straight hours. There are people that do it, but baby Henry's only 6. All right, on the next page, we have some practice problems. If you're feeling confident, you can hit pause and do these on your own and come back for answers. If you are not feeling confident, you can just stay on and we'll do them together. All right, so the first one, it says, is there a correlation between rides given by a taxi driver and their total earnings? I would say yes, this has got a pretty strong positive correlation. I'm gonna estimate a trend line. Yours might look a little bit different than mine, but there's mine. I'm gonna say this is a positive linear trend. And next I'm gonna identify the slope of my equation. I'm gonna pick 2 data points that I think are really close to my line. I'm gonna go with these 2. So my slope is up 75 and over 2. It's not really ideal, but that's okay. Y-intercept of my trend line, it's crossing at 0. So I can write in my equation. Y equals mx plus b would be y equals 75 over 2 times x. It would be plus 0, but I don't really need it. So I'm just going to say y equals 75 over 2x. I should be able to use that equation to predict any future information. Like if I plugged in number of rides given, I could solve for the amount earned, or I could plug in some money and find out how many rides were given. All right, next one. Is there a correlation between the value of a home and its monthly rental rate? Definitely looks like there is, so I'm gonna estimate a little trend line in there. This trend line makes a strange assumption, but we'll see. So I'm gonna say, yes, this has a positive linear trend. Identify the slope. I'm gonna look for some nice intersections. I don't really see any good ones. I mean, this one's definitely good. And so is this one. I'm gonna go with those 2. So I'm gonna say it goes up 200 and over 50. So 200 over 50, which can reduce to 4. So I have a slope of 4. Y-intercept, this is going up by 200, so this would probably be 100. Looks like it's a little higher. I'm gonna say like 150. So slope-intercept form, I'm gonna say y equals 4x plus 150. That's my equation. So this assumes, this is in thousands of dollars. That's in regular dollars. Oh, that makes a big difference. That's okay. All right, last one. We're looking to see if there's a correlation between the number of hours of a rainstorm and the total number of inches of rain. Okay, so first thing, we have to plot these. They're not plotted for us. So I'm gonna plot each of these points. Here's 0, 0, 1 and 0.5, 2 and 1.1, 3 and 1.8, 4 and 2.4, and 5 and 3. I would say that's definitely got a positive linear trend. I'm gonna draw my trend line. And to find my slope, I think I'm gonna go right up to here. I'm gonna say we got 3 inches of rain in 5 hours. So I'm going to make my slope 3/5. For my y-intercept, we're crossing right at 0. So I'm going to fill this in. I have y equals 3/5 times x plus 0, but we can simplify that and just say y equals 3/5 times x. So in our next videos, we are going to be looking to see if these make sense and if we can use them to predict future data. And what I mean by that is if I plug in a future value of x, is this rate going to make sense forever? If I plug in a home value way out here, is this rate going to make sense forever? And if the storm continues on and on forever, and I ask how much rain there's going to be on some future number of hours, we want to see if our equation is going to hold up. So that's going to be tomorrow. See you then.